Okay, this lesson is on what is called completing the square. Completing the square is a method used to get, it's used a bunch of different ways, but it's used to get either a quadratic that's in standard form into vertex form. It also gets circles into the circle form. So you can even solve equations by you can even solve quadratic equations by completing the square. So completing the square is very useful skill to have, whether you're doing work with parabolas or circles. But we're going to use it to prepare us for working with circles, since circles require that things are in a specific form. Completing the square helps us get there. So we're going to show you how to complete the square with a series of quadratics here, and then we will, in the next lesson, apply that to circles. So essentially, it's going to look like this and then end up looking like this. So we'll try a problem, and then I'll let you try one, and we'll try a different type of problem, and then I'll let you try that one, and then we'll sort of go like through easy, medium, and hard, and let you work through each one, checking your answers each time. Okay, let's look at the first problem. The first step in completing the square, let me adjust my thickness here. There we go. The first step in completing the square is to put parentheses around your x's. First, we want to make sure that everything's on the same side. But in this case, it already is. So we're going to put parentheses around our x's. Then, second step is to look for a GCF that you can take out. Now, in this particular case, there is no GCF. What I mean by GCF is a number. We don't want to take out the x's because then that gets rid of our quadratic that we're trying to. You could certainly take out an x, but when you're trying to complete the square, you don't. You just want to take out any numbers. What you want to see, the perfect scenario, is to see where your a is 1. If your a is not 1, you need to divide whatever number is there out. So in this case, our a is 1, so I don't have to do anything. So now what I'm going to do is I'm going to rewrite this, but I'm going to leave a little bit of room to complete the square. Okay? Equals y. This is a parenthesis. Now the reason why we leave this room is because we need to add a c. We need to add that c term, and this is what's called completing the square. The rule is to take this c value right here is half of your b squared. So whatever your b is, cut it in half and then square that number. So 4 cut in half is 2. 2 squared is 4. So this will be a 4. Now the problem is that we can't, the way equations work, you can't just add a number to one side without adding a number to the other side as well. But the problem with that is we need everything on the same side. So yes, because you added a 4 right here, you would have to add the 4 to the other side, but we're eventually going to have to move the 4 back anyways by subtracting the 4. So if you want to think about it and skip that whole step, whatever number you place here will just be the opposite right here. Notice how they're the opposite. Because if I add a 4 here, I would have to add a 4 over here, but then bring it back over here by subtracting it. So whatever's here, it's the opposite here. So let me see if I can. Yeah. So we don't need this anymore over here. Now, the whole purpose for doing this is that it gives us a perfect square trinomial. Perfect square trinomial means that the same number will multiply to be this and add to be this. What same number multiplies to be 4 and adds to be 4? If you said 2, then you're correct. So it's 2 and 2, right? 2 and 2 add up to be 4, 2 times 2 multiply to be 4. But instead of writing 2 twice, we just write it as x plus 2 squared. And negative 7 minus 4 is negative 11. That is switching it from vertex form, or from standard form to vertex form. That is also how we complete the square. So let's recap. First step, put parentheses around your x's. Second step, if there's a number in front of your x, you need to divide it out. Otherwise, leave it the same. You're going to rewrite it here, leaving some space to complete the square. To complete the square, you take half of your b and square it. That number goes here. Now, since we added 4 here, we would have to add 4 over here, but then eventually subtract it back over here. So if you just remember that these are the opposite signs, 4 here, so this is negative 4 here, that'll be much easier. And then we factor it. What multiplies to b4 and adds to b4 is 2 and 2. So instead of writing 2 twice, we just do x plus 2 squared. And then minus 11. Use that as a guide as you complete the try problem to the right. Pause the video, and then when you're ready for the answer, hit play. Okay, so let me recap what we did here. There's the answer. So what we did, again, is put parentheses around our x's. If there's a number out front, we divide it out. There is none in this case, so we leave it the same. So we write x squared minus 6x again, but we leave room to complete the square, and then minus the 4. To complete the square, we take half of your b and square it. Half of negative 6 is negative 3, and negative 3 squared, or negative 3 times negative 3, is 9. We would have to add the 9 over here, but then eventually subtract it over here, so we just subtracted it from over here, right, as opposed to doing 2 steps. We just did the opposite right there. Now this is a perfect square trinomial, so it means the same number will multiply to be 9 as add to be negative 6, and that number is negative 3 and negative 3, because negative 3 and negative 3 is this, and negative 3 times negative 3 is this. So instead of writing it twice, we just write x minus 3 squared, and then these add to be negative 13. And that is completing the square. Now, let's try a medium problem. Medium problem. Same first step. We should place parentheses around our x's. Now, like I said before, if there's something in front of your x squared, we want to divide that out. We can't have something in front of our x squared. So I'm going to divide that out, meaning I'm going to factor out a negative 3 from these terms. That becomes x squared. And 12 divided by negative 3 is negative 4. We leave some room to complete the square, and minus 10. So all I did was divide these by negative 3 and factored it out right here. Okay. Now, to complete the square is taking half of your b and squaring it. Half of negative 4 is negative 2. Negative 2 squared is 4. Now, before we jump over into automatically doing negative 4 over here, we can't do that. Because we factored out a negative 3 here in the first place, this isn't actually 4. Okay? We divided this term by negative 3 and this term by negative 3, but this term never got the dividing by negative 3. So this actually isn't the number it originally was. The original number is actually these two multiplied to each other. 4 times negative 3. So the actual number is actually negative 12, which means we have to add 12 here. That is probably the most confusing step out of all of these. So we'll keep practicing with that. Okay, again, half of my b squared is 4, but remember, because there's a number out front, this is not actually 4. It's 4 times negative 3, which is negative 12, which means we add 12 here. Now this becomes a perfect square trinomial. The negative 3 is still on the outside. What multiplies to be 4 and adds to be negative 4 is negative 2, so that's x minus 2 squared, and negative 10 plus 12 is 2. And that is a medium completing the square. So go ahead and try the problem here, and pause the video, and when you're ready to check your answer, hit play. Okay, so there's our answer. Again, to recap, put parentheses around the x's. Because we have a number in front of our x squared, I had to divide both of these by that number. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. And that 2 just comes on the outside. We left room to complete the square, so half of my b is negative 1. Negative 1 squared. Negative 1 times negative 1 is 1. But that's not actually 1 because there's a number out here. It's actually 1 times 2. So the actual number is 2, which means I have to subtract 2 out here. And the perfect square trinomial, what multiplies to be 1 and adds to be negative 2 is negative 1 and negative 1, or just x minus 1 squared. And then negative 2 and negative 2 is negative 4. That's it. Now we'll try the hard one, fractions. These always give people a hard time, but we're going to try it anyways. Okay? Put parentheses around our x's. Because our a is not 1, we're going to need to divide this 1/4 out, essentially dividing by 1/4 and dividing by 1/4. Now this is a 1 right here. That 1/4 will come out front and be x squared. This is the tricky one right here. Negative 1 divided by 1/4. Essentially, you're asking yourself how many fourths or how many quarters go into 1. Well, quarters into 1 is actually 4. Negative 1 divided by 1/4 is negative 4. Leave some room. If you don't believe me, go ahead and put that in a calculator and you'll see that that is the answer. And plus 9. We left room to complete the square. The completing the square part is half of our b, which is negative 2, squared is positive 4. But remember, that is not actually 4. It's 4 times 1/4. Well, 1/4 of 4 is 1. So the actual number is 1, which means we have to subtract 1. So now we have a perfect square trinomial here. So what multiplies before and adds to be negative 4? We'll put that there, and y equals is negative 2. So it's x minus 2 squared, and 9 minus 1 is positive 8. So that is our answer. Now, go ahead and try the try problem to the right, and play the video when you are ready to see the answer. Okay, there's the answer. So again, parentheses around our x's. Our a is not 1, it's negative 1, so I do have to divide that out. Negative 1 comes out. You divide by negative 1, divide by negative 1 is what we get. Left room to complete the square. Half of my b is negative 9 squared. Negative 9 times negative 9 is 81. Now that's not actually 81, it's 81 times negative 1, so it's actually negative 81, which means you have to add 81 out here. It's a perfect square trinomial. What number multiplies to be 81 and adds to be negative 18 is negative 9 and negative 9. So we write x times negative 9. And then so negative 75 plus 81 is 6. What you might have noticed in all of these problems is that the number that is in your final answer here is just half of your b. So if you just remember that negative 18, half of that's negative 9, that can lead you right to your answer right away. Notice in all of these problems, okay, here, negative 4, negative 2, half. Okay? Here, negative 4, negative 2, half. Over here, negative 2, negative 1, half. Negative 6, negative 3, half. And 4 and 2, half. All of these have a half of what their b was. So, if you have any questions as you're going through this, please stop and ask me the questions. Otherwise, you'll go on to the next set of lessons, which is using this to do circles. And then from there, I believe there's a worksheet. So if you have any questions with this, please stop and ask now. Thanks.